Good morning, good afternoon, good evening to people around the world. This is Martin Hubel, your host of the Db2 Night Show, and we are back for season number 14. I think I should have some sound effects around saying that, but it's rather interesting just how long this little show has gone on and how many people we've helped through the Db2 community through the years. We're very pleased to kick off this auspicious occasion with one of our regular guests, George Backlars from the IBM Toronto Lab. He's now got a very nice title. I made sure to get it on the slide there for you. How are you doing today, George?
I'm doing pretty good, thanks. Martin, yourself?
Good. It's a nice hot day again. We got the pool heater on. We'll be swimming later today, and we got a birthday party tomorrow, so it's going to be great. I'm one of the honorees. We have our August birthdays. We moved to September this year, but we're all here, and it's going to be great. So let's get the housekeeping out of the way so you'll have as much time as possible. We'll move on to the next slide, which is our social media page. Please follow hashtag Db2Night to get news on the show. That's one of the easiest ways. I also put emails on the iDoug's DB2L server. You can also get announcements there. Replays are available through the replay blog on the DBI website, but we also have replays available now in our own YouTube channel, which you can follow as well. And once things are posted on there, I try to tweet about it so you know when they're available. I try to get those up today. There's our famous disclaimer and our copyright information, etc. And it talks about trademarks and how we respect them and other things of that nature. So moving on. What we'll talk about, the announcements, upcoming shows. We've done pretty well on the Db2 LUW side in terms of identifying all of the speakers and topics. Well, we're doing better, let's put it that way. Next month will be an update on PureScale, and that'll be someone in the IBM Toronto Lab. I'm waiting on a speaker name, but I know that if you're interested in PureScale, you will want to hear that. After that, Les King will be speaking. He's given me 3 topics to choose from, and I'll have a look at that. Some of that can be Db2 update material and other topics. And on December the 2nd, Kerry Romanoff, the Db2 architect, lead architect, will be speaking on the next point number. I continue to point out that the people in the Toronto Lab have a rather rare condition known as dodecaphobia. It's kind of like triskaidekaphobia, which is the fear of number 13, but in this case, it seems to be the fear of a number 12, which is a dodecaphobia, because they seem to bring out these more and more 11.5 point releases, which is nice to see, but I'm not sure why they can't just move that number up. On the other side, I've been speaking with the IBM folks in the Silicon Valley lab, and they have asked for a couple of time slots. I also have some other vendors as well, so I'll be filling in those dates shortly and have that up on the website for you to register. As always, we have our primary and founding sponsor of the Db2 Night Show is DBI Software, and they're quite happy to, or would like you to keep them in mind if you're considering performance solutions for Db2 LUW, and that they have information on their website regarding their latest and greatest products. They recently brought out a new release of their web performance suite. Our winner from our last show was Anthony Kugler of Dillard's, and he's getting himself or already received an Amazon gift certificate. And our next thing just has our sponsors again, which is DBI and yours truly, Martin Hubel Consulting, Inc. And there we go. Now, the last thing we have, or I guess the humorous picture, is I went out shopping on a really hot day in July, and I told you we had 2 new co-hosts, and there they are. This is Lacey on the top and Lily on the bottom. I have a nice bald head, and they like to lick it. So there they are, cleaning me off as I came in from my shopping trip. It's so nice of them to help me out. So it's a the strange things that go on in our house with two chihuahuas. These guys these girls are just loving, and they're hilarious. They're having a great time with them. Okay, the next thing is our polls. We've got some polling questions as always. Let me just bring those out, and we'll get the studio audience feedback on some topics here. First one is kind of just with what we've gone on with all of the stuff in the last few years. I thought I'd ask this, see how people are feeling in terms of optimism or not. Okay, we'll share that result. And people feel things are getting better. That's a good thing. Things are finally returning to normal up here in the Toronto area. Things are opening back up. There are still some things closed. There are still some concerns, but they're working through it, and they're putting procedures in place so that life can be continuing to get back to normal. My mouse seems to be needing a new battery or something. It's giving me all sorts of trouble today. What versions of DB2 are you currently running? Notice how things like 10.1 are starting to fall off the bottom.
Hey, you know what the theory was why we do point releases as opposed to version numbers?
I'm going to take a guess, and it relates to money and other things like that.
Pretty close. And it's usually associated with packaging changes and stuff, but also if there's major changes to the catalogs and stuff, which can't be done in just a simple fix back upgrade, right?
Okay. But they
but money and packaging, that's pretty high on the list too.
Yeah, they could lower the price when they bring out a new release. Hint, hint. Little humor there. Little marketing humor. Yeah, I think definitely need a new battery in this mouse. All right, so we have normal collector series there. Most people are running the newer 11.5, which is a good thing. And the last, well, we got two more questions. The first one here is, how many databases do you estimate that your company has? The other question is, how many DBMSs or instances and databases you actually have to manage? And we got everybody voted there, so I'll share that. We got the range there of a few to a lot, which is kind of typical. When I first saw these numbers and talked to people at various companies back 20 years ago, people had 100 then or more. So to see 1,000 is not unusual. And we have, oh, come on. I'm clicking on this thing and nothing's happening. All right. How many hours would it take you to move a database? That one didn't take. Let me try again. There we go. Sometimes I click it and it clicks twice, and then we don't get to see the poll at all.
Yeah, my favorite is I don't like doing it. Yeah.
It gives you something to do. This is interesting to see.
Mm-hmm.
All right. Everybody's voted on that. Close that off and share it. A couple of people say a couple of hours, and one says within a week, depending on change procedures and all sorts of things and what else is going on, I'm sure. Okay. Yep. And that takes us to the end of our polls for now. So I'm going to close that off. And George, I'm going to come over here, and there you are. And whoops, now I need to click on you, make you the presenter, and you should have that message come up, and we'll see your screen in just a half a minute here. There we see you.
Fantastic.
Great. So take it away. I'm going to mute myself, and I'll watch the question queue as always.
Right, great. Thank you, Martin, and welcome everyone to this session on Db2 Click-to-Containerize. So I'm going to kind of take you through a journey of what the tool is, why it was created in the first place, and then also take you through some of the enhancements we've made since this tool originally came out. So for those of you who don't know, Db2 Click-Containerize was a tool that allows you to containerize your Db2 instances, databases, into Cloud Pak for Data, OpenShift, and Kubernetes. So it was released last year in the summer, and we've done a lot of work since then to kind of upgrade the capabilities of this tool. So I'm going to take you through, first of all, how it works, what it does, and then take you through some scenarios and examples of the actual tool and working, okay? So we're going to first take a look at basically what is Db2U, which is the containerized version of the Db2 engine. Then we'll look at Click-to-Containerize itself and what's kind of new from version 1. And then we'll go through some of the shift scenarios and show you how I would use it in my organization. And finally, I have a bunch of resources at the end that you can use to get more information on the tool and documentation, etc. The presentation itself will be made available after this session is done. So you've probably heard lots of people talk about the containerization benefits, right? Moving into the cloud using things like orchestration services like Kubernetes and OpenShift and Cloud Pak for Data. So there's lots of nice benefits behind it. So you see all these numbers and stuff that come out from different studies about how it's 81% less human error and a consistent UI makes it easier to use, etc. But if you ask customers, what about databases? How do they fit into the containerization benefits? And you'll find that there's a lot of concern about using databases because the database itself has to fit into this environment properly, because the original use of containerization was for applications that really didn't need persistent storage, a web server, right? Some types of apps, they didn't need persistent storage. As soon as you get a database in there, we have to handle things a little bit differently. A lot of the databases that are in the market have not been originally designed for a containerization environment. So even DB2, you couldn't stick it into a container today in its existing form and have it work properly. One of the things is you have to make sure that the database works within the frameworks of the operators of the containerization environment so that it knows how to act properly when certain things occur, right? Certain events. So really, you want to have a database that's designed for this environment, has persistent storage, performs well, right? And you got to make it easy to deploy, for recovery, for all those sorts of things. So it's been a journey from a DB2 perspective. So we have done presentations before on Db2U. One thing I do want to point out is that the Db2 cartridge has really been in existence since about 2016. We started with Docker, and you can see there's been a number of enhancements over the years. And what this required us to do was change parts of the Db2 kernel so they worked properly or within the confines of a pod or a container. And so what you end up getting is really a native Db2 pod, works properly within the environment, works within the orchestration of Kubernetes and OpenShift, right? It works within the security framework, within the the disk frameworks, etc. So, there's been a lot of effort to make sure this works properly. Now, what hasn't changed is that the Db2U cartridge has exactly the same capabilities as the normal Db2. That means all the SQL, all the commands, all the functions, everything continues to work as if it was a standard Db2 instance. So this is no different than running a regular Db2. The only difference is that we've made some architectural changes under the covers so that when it runs in a pod, it is properly communicating with the cluster. So you can get Db2 containerization. This is part of your Db2 license. So you are allowed to take a Db2 license that you may have already for an on-premise Db2 and run it in a container. Okay, so it's just a different, think of it as just a different executable. So it's available from a catalog where you can get it on Red Hat OpenShift, you can get it in Kubernetes, and also in Cloud Pak for Data. It's built in as a database that you can deploy. You just need, of course, the proper licensing to do it. And there's lots of benefits from running Db2U. Okay, so these are just some of the numbers you may see about terms of faster installation, automated upgrades if you want, right? We have HADR capability within Db2U. We can do very quick pod failures, probably within a couple minutes. In fact, there's stuff that's built into Db2U that you may have run scripts and stuff in the past in order to do, whereas it's automated now in a containerized environment. So a very simple one would be managing Db2, making sure that it's up all the time. So for instance, as part of the Db2 framework or the pods that are running, there's a process that sits there that watches the Db2 instance that's running. And if it sees that it fails for any reason at all, it will automatically restart it on your behalf. So there's a process working in the background. Okay, so it detects failures and restarts the database for you. If OpenShift or Kubernetes determines that the pod, the physical pod that Db2 is running in, fails, it will also do an automatic restart for you of the pod. And then within the pod, we have the automatic recovery. So those types of things are all automated for you. On top of that, you can add HADR or other ways of kind of keeping that system running across members, for instance. So there's a lot of automation. It's very, very quick in terms of installing and getting a Db2 up and running. This can be either standard OLTP type Db2s or SMP or even MPP. And you can have columnar format, row format. Almost every version is supported. The only thing we don't support currently in Db2U is PureScale. So if you do attend the session on PureScale later in a later session on Db2 Night Show, that would be a good question to ask, is when are we going to see PureScale running in a containerized environment? Because that is a very key feature that I think a lot of people are looking for. And so trust me, we are working on that. It's a high priority for us, but it currently is not available in an OpenShift, Kubernetes, or CP4D environment. So how do I get to a container? This is the number one question, is all right, you convinced me that it's a good idea to use OpenShift or Kubernetes or Cloud Pak for data. How do I get there? Well, you obviously have to do some kind of data movement to get that database in there. Now, creating one from scratch, of course, is quite simple, but if I've got existing data, I want to get it in there, what do I have to do? So as you know, with any migration, you got to plan it, decide how much is that going to cost you to do it, because obviously there's resources. How am I going to move the data? Do I need to export it, unload it, right? Because traditional methods may not work, right? And then how do I verify it? So, there's obviously a lot of steps involved in migrating to containers. So the next question you ask is, how do I do that migration? And here we've got really two options. We've got what I call a logical view and the physical view of the database. And which way you look at it determines how you do the movement. So when I talk about logical view, that means I'm going to use some kind of utility to extract the data. That means whatever I have in my database, whether it's encrypted, compressed, row table, columnar table, it just gets extracted as a flat file of some sort. So I externalize the data, then I have to move it to the new location, and then I re-import it. And then of course I have to rebuild all the stuff I had before. So procedures, views, indexes, MQTs, statistics, etc. So there's a lot of work involved in doing that. The second side of it looks at the physical view. And this is an example where, let's say, the question asked about how long will it take you to move a database. Well, if you could just do a backup and a restore, that's a hell of a lot simpler, isn't it? However, we still have to make sure we move all the file objects over to the new location. And I may have to do a relocation. So relocate, right? DB. Need to be able to move the objects into the new location, into the proper directories, and have DB2 kind of redefined so it understands what the database looks like. And then I can start. None of the beauty about the physical side is I never had to expose any of that data, nor did I have to recreate all those objects. They are actually inside the database. So here's the traditional view. If I wanted to export my database to a new location, I'm going to export all the tables in a readable format. I import and load, and then I got a whole bunch of to-dos, right, to get it up and running. And by the way, this may be the only way for you to migrate from one architecture to another. So what I mean by that is if you're running on AIX today and you decide to move to an x64, Intel-based Linux, you're going to have to do an export. And the reason is behind the architecture of the integer format, right? Big endian versus little endian. And there is nothing I can do from a file system perspective to get that to work. I have to export and import, and that would be your only option in that environment. However, with C2C, if you've got a system that's running on Linux, so Linux on Intel or Linux on Power Little Endian, okay, take your pick, it doesn't matter. I'm able to move those systems directly into a container running either on Cloud Pak for data, Kubernetes, or OpenShift. None of the data is ever exposed as flat files. Everything is kept in its original file format. So if it's compressed, it remains compressed. If it's encrypted, it remains encrypted. So all of the copying is done at file level objects. And then it's shifted into a container, relocated, and at the same time, it can also do an upgrade for you. So just think about that. You've got a 10.5 database. When you go to a container, the containers are running 11.5, 7 and above images. So that means I have to do a migration, right, and an upgrade. So where do I do that? If I was doing, if I'm doing export and import, well, then I guess I'm moving to the new environment, so I don't have to do an upgrade. But if I'm physically moving the database, I'm going to have to do the upgrade before I do anything, right? So this tool will do that on your behalf. As it's moving it to the new location, it will invoke the upgrade required to get it up to the latest version of DB2. So all of this in a single utility. Okay, so Click-2-Containerize is a single utility. The actual name of the code is called Db2 Shift, but the idea behind it is it does all of this stuff on your behalf. Okay, so where it comes from, x64, a Power Little Endian server, anything from 10.5 to 11.5, and we can take that database and place it into a public cloud, right? So we can put it onto an instance like an EC2 instance, which we just like think of VMware, right? Sitting on somebody else's hardware. Onto SUSE, Red Hat, Ubuntu, CentOS, or we can place it into a containerized environment. So that would be EKS, Amazon's EKS service, IBM Cloud Pak for data, OpenShift. We're also looking at other environments like Azure and Google Cloud. Those are still to be certified. Or like I said, we can place it right into a traditional instance running in a KVM, Hyper-V, VMware. So you can go from an instance to a container or an instance to another instance. So the tool isn't just for containerizing into a, like I said, OpenShift or Kubernetes environment. We can also take your database and shift it to a traditional DB2 server. So I have customers, from their perspective, they think of modernization to say, get it off of my machine floor and put it in somebody else's machine. So in this case, let's move it to a EC2 instance on Amazon. And I'm going to run it up there in one of their VMs. And to me, that's modernizing my system, right? Other people say, no, I really want to move it into a containerized environment, and we can do that too. What other cool thing that we have with the utility is we can do the reverse. So if you've decided to containerize something and you're not happy with something to do with that environment, I can move that to another cloud. So I can move from one cloud to another, or I can move it back out into a traditional instance. So we give you that ability to back out your changes. So there's a lot of power behind the utility itself. So there's lots of things that you can do with it. So if you need to move from AIX or ZOS DB2 to a traditional Linux or container, you're still going to have to do what we call an export and import. Use something like our DB2 migration utility, right? If you need to change code page, or you're coming from an older release that we don't support, so let's say 9.7, right? You're going to have to unload this stuff. If you only want to do a subset of data, you only have SQL access. If you want to change your topology, so what this means is, let's say you do have a DB2 Linux server running DPF, and you have 8 MLNs, right, or 8 worker nodes, and you decide when you go to the new environment, you want to change to 4. Well, you can't do that with C2C. It has to be exactly the same number, so 8 to 8, right? So you would have to do a migration if you wanted to change the topology, right? One other thing to realize is that if you are going to do a migration by exporting stuff, the data is going to have to be decrypted, right? So that's an exposure point, something that you need to make sure that you have security around these files. So click to containerize any Linux to Linux, including power little endian. So we have done successfully an x86 database moving into a power little endian. And you know, that may sound far-fetched, but there are some customers who upgraded their power equipment. They're running AIX. They've moved to Power 10. They've got a bunch of Power 9 boxes available. Why not make them Power Little Endian? And you can run a bunch of x86 servers on Power Little Endian. So there is an opportunity to reuse some of your hardware. We will upgrade 10.5, 11.1, 11.5. We move the entire database. So there's no subset. There's nothing left behind. There's no need for you to do any kind of additional work on the database. We move everything as is. So that means anything that's in the database, when you move it, will be at the target location. Okay, we never expose the data. We just move the file level objects. It's all done securely, right, using encrypted communications across the network. So what I'm going to do is I'm going to show you a demonstration scenario. So I have a DB2 database running on Amazon. It's an EC2 instance. It's running a TPCH-like database. It's 100 gigabytes in size. It compresses down because I'm using columnar format here. So we're thinking about 30 to 40 gig when it's compressed. So what I'm going to show you here is my Amazon server, and I'm using VNC just to show that it's here. And what I will do here, for instance, is let me just say DB2. And I will say connect to CQW call. So this is my database that's on here. I list tables. You'll see I got a bunch of them. So this is the traditional kind of TPCH benchmark tables. And what I'm going to do is ask just for a count from my store sales, because that is the largest table in this particular system. And we should have about 287 million rows in this particular system. So there you go, 287 million. So we're just going to quit out of this. And if any of you are familiar with OpenShift or Kubernetes, we are able to communicate with my cluster and say what pods are running. And you can see this is an example of output from Kubernetes saying, as you can see, these are all the DB2 components. There's the DB2 database right there that's running called DB2U0. And there's some other things that we have here. etcd or whatever is basically watches over DB2U to make sure that it continues to run properly. There's some jobs that were created here. There's the LDAP services if I want it. So what I can do is I'm hoping that I've got this command in here properly. Say DB2U. And that basically I've shelled into the container that's running in Kubernetes. So here what I'm going to do is I'm going to become DB2 inst1. And here I can say DB2. So I'm running just like a DB2 user here. You know, there's no difference in a container, right? So my database here is called BlueDB. And let me list the tables. And you can see it's a completely empty database. So this is what I've got. Think of it as a shell. So when I want to move with Click to Containerize, I create an empty shell wherever it is, whether it's on Kubernetes, OpenShift, or Cloud Pak for data, because I need a target to do my work, right? So I'm going to exit out of this now. So here is the DB2 shift command. And I'm going to just start it up the traditional way. And you're going to see more examples of how this works. So the first thing you see it is the latest in VT100 technology or 3270 technology. We've decided to build the shell using this kind of format because it doesn't rely on a proper GUI to be available in the operating system. So for many systems, they're headless, right? There's no GDDM or there's no X server running for me to get proper, you know, graphics and all that. So we just use completely terminal-based graphics. So I'm going to hit enter, and I'm going to say shift the database to Cloud Pak for data, Kubernetes, or OpenShift. So I've pre-populated this. You can see I've basically said database name, who's the instance owner, where am I going to, OpenShift or Kubernetes, what's the target database. These are things associated with OpenShift or Kubernetes. I need to know what the project is. In this case, it's DB2U, and what's the name of the pod. All the stuff below this line is optional. The stuff above it, that's all I really need to move my database. So I'm going to say review. Okay, that is the command line version. So I can just cut and paste this now and run it as a separate command. I don't need this UI that you see in front of you. Okay, and then I can say execute. Now it's going to go off and do my shift. So we're going to let that run. And then think in back of your mind how much time you think this is going to take me. Okay. So here's what our targets can be. So I'm going to run this utility. Where can I go to? Right. So I can take my DB2 and I can shift it into OpenShift 3.1.1 and 4+. We can go to Cloud Pak for data, anything greater than 3.5. The latest Cloud Pak is 4.5, so most people should be moving to the latest versions. For Kubernetes, we support distributions of 1.19 and above. And you can also use Micro K8 or Minikube for small systems or for prototyping and testing. And from an operating system perspective, we support all of these different versions of Linux. So if your DB2 is sitting on any one of these systems, we can run the utility in there and shift it to any of the OpenShift's, Kubernetes, or Cloud Pak for data systems. So pretty wide range of stuff that we can run on. By the way, the OpenShift distributions, OpenShift on Power Little Endian is also available. So I can use Power Little Endian Linux, move it into Power Little Endian OpenShift. I can also move an x86 system into Power Little Endian OpenShift. So as you can see, there's some cross-hardware support here. Now, the shift modes have changed. So we do some new things in this latest version of DB2 Shift. We can go from an instance to another instance. So think of it as a traditional DB2 backup restore to another DB2. We do that with the utility. We can also create the target database if it doesn't exist. So you just have to have the instance up and running. We'll go do the create for you and move the data over there, right? We can also do HADR setup for target and source, both a pod to an instance to a pod or an instance to an instance. We can clone databases without requiring any information about where it's going to go. So this is really, really useful for those environments where you have no direct connectivity. That means I might have DB2 sitting on a traditional server, but I cannot connect to the cluster because it's air-gapped or it's been, isolated. So cloning says, let's take your database, we take out all the stuff we need, we place it into a file, into a directory basically, and then you move that directory. Either zip it up or place it somewhere in, object storage or whatever, then get DB2 Shift, place it over in the new location, and then we deploy there. And we can deploy it multiple times. So think about it for a minute. Let's say you have test and QA systems, and you're always continually creating these things. Well, what you could do is take a clone of your production system. You may want to cleanse some of the data beforehand, but anyways, you create a copy of it, and then you can deploy it as many times as you want to whatever system one. You can say, hey, I want to put it on another traditional DB2 instance. Well, clone it, deploy it, done. Take the same copy, and now I can put it into an OpenShift container. I could take the same copy, let's place it into a Kubernetes on AWS. Doesn't matter, we can continually use that copy and deploy it wherever you want. And finally, what we've also done what we call a reversed shift. So that means that if I'm running it on a container and I say, I don't like it there, it's not really, operationally or performance, or something you don't like, we can take it out of there, place it back into a traditional DB2 instance for you. So it gives you a lot of flexibility. You can go down this path and you can change your mind. It's not kind of like a one-way street, right? So here are the things that DB2 Shift does. These are what we call scenarios. So these are the ways that I can use the utility. I have two different types of shift operations. I can shift your database to OpenShift, Kubernetes, or CP4D. So this is going into a container or a pod. I can also do a shift to a traditional DB2 instance. So we can move it to another DB2 somewhere. Okay, those are shift operations. Clone and deploy. Clone will say, take a copy of the DB2 database, and then we create an image that you can then later deploy. So think of it almost like a backup copy, right? So you should treat that image just as if you would a backup copy. You shouldn't, let it sit around, right? It should be, secured, right? But then I can take that copy now and I can deploy it to a traditional OpenShift Kubernetes or a CP4D, or I can deploy it to another DB2 instance. So similar to the two shift operations, except now we're just using a copy of your database. Then from an HADR perspective, we can set up HADR between a traditional DB2 and a target pod, or HADR between a traditional DB2 instance, source and target. And then finally, we have something called initialized DMC and LDAP authentication. So this takes a little bit of explanation. When you shift into Cloud Pak for Data, it has Data Management Console built in to Cloud Pak for Data. In order for Cloud Pak for Data's DMC to understand that DB2 is part of this environment, it injects some control tables into the database. And it also has to have the LDAP set up so it talks to the Cloud Pak for Data LDAP services. So when I create a DB2 pod and I say shift into Cloud Pak for Data, we will do that for you. We will set up the DMC control tables, we'll set up the LDAP so that when you get back into Cloud Pak for Data, you'll be able to manage that database. When you do an HADR connection, the problem is I can't do any of that injecting of new tables and all that sort of stuff because it has to be an identical copy of your original DB2 system, which is sitting on an instance somewhere. So that pod will not be manageable or viewable from Cloud Pak for Data while it's acting as a standby. So the idea is that eventually you'll be happy that pod is caught up, it's running, whatever, and then you do a swap, right? You make it the primary DB2 and you kind of cut the other one, or maybe you keep them in sync still, but you make that one the primary. At that point in time, you need to tell Cloud Pak for Data it now exists. So this little utility, the DMC and LDAP authentication, will inject the control tables, update the LDAP, so now you'll be able to view it from a Cloud Pak for Data point of view. But until that point in time, as long as it's a standby, we can't do it. It has to be the primary before we can do that final step. And then finally, there's one more utility. This is where I have created a clone copy of the database inside a pod, and I'm able to extract it and move it somewhere using the copy clone feature that we have. Okay, so now we're going to go through each one of these. I'm going to show you how those work. But before we do, let's just take a quick look at a couple things. There, my shift has finished. So while I've been talking to you, we've completely moved my 35 gigabyte database over to Kubernetes on Amazon. These are all running in a managed service for me. So if I go to the bottom of this, it took 204 seconds to move this database. So let's just double check that it really did do what we thought it did. So we're going to go into DB2 inst 1. We're going to connect to BlueDB. First of all, we'll make sure that our tables are there. And there you can see they've all shown up. So let's just do a select count. Oops. And without any luck, we have 287 million rows that have moved. So there's the power of C2C. As a DBA, I'm able to move this database with everything in it, including all of your indexes, views, MQTs, you name it. We've moved it over to this environment in its entirety. So the only thing you need to do at this point in time is to run your applications against this to verify that, yeah, it is working exactly as you would think. But this is exactly the same in terms of concepts anyways, from a backup and restore. The only difference is that we've moved all the file systems objects in parallel across the network, rearranged them, relocated them into the pod, and now made it available as a database inside Kubernetes. And this could have been Kubernetes, OpenShift, or Cloud Pak for Data. There's really no difference from your point of view. These will all look the same. Now, I did mention that this utility runs as a basically as this character type of GUI. We are going to go through some more examples, but let me show you on my system here. I'm running on a Mac. This could be Windows. This could be anywhere else. I am SSHing into this server that I was just running that you saw. Let me just log into that user ID. And if you notice, I can run DB2 shift from here. And now I'm running on my Mac through a terminal window running the utility. So there's no need for me to have a VNC connection to that server. I could do it all through SSH connections. So that's one of the beauties of using this type of interface, even though it looks kind of dated, but it allows me to do these types of things without having a full-blown GUI to execute. So let me exit out of that. And now let me take you through an environment that I'm going to demonstrate a number of these different steps to you. Before I do that, anything you want to open up, Martin? Anything questions you want to ask, or do you want me to continue on?
I think you can keep going. I don't see any questions in our queue here.
Okay, great. So what I'm going to do is I'm going to shift now. Okay, thank you. So I'm going to show you a little cluster that we've created. The cluster itself is made up of 3 machines. And I'm showing you an environment called SkyTab. What SkyTab is basically a hosting service that allows me to place VMware images up there and run them in their environment. And so what I've done is I've created a little cluster here with 3 machines. One is running Kubernetes. Okay, I've got a micro K8 server here. And I've got 2 Db2 servers. And what I'm going to do is do some shifts between these machines just so I can show you examples of how this stuff works. So my server number 1 is here. And as you can see, it's kind of like, again, I'm VNCing into the server. I could use direct connections with SSH on the Mac, but this just looks prettier. So let's first start with the shift. And the shift command can be done, again, through a command line, or it could be done through the UI. So if you are interested, we have given you some links on the documentation. So it's at the bottom of the presentation. But let me just show you C2C guide. So this is the online documentation. So we have all sorts of details on how to use the user interface, the authentication, command line options. And we also do it by scenarios. And scenario is probably the easiest way to really get started using this utility. So if I want to do a shift to pod, this gives you all the different parameters that you need, the required options, optional, shows you the UI, and then it goes through every single option. And what does it mean? What should you use as a setting, the command line options, and then for every one of these, it'll give you details of what you should be typing in there. Okay, so we have examples on all this sort of stuff. We also have information on considerations for when you do a shift. What do I do with migrations? What about target locations? Storage replication, threads and compression, all sorts of stuff is in here that hopefully will make your life easier when it comes to performing a shift. Now, this documentation is also, there is some of it in the Db2 Information Center. Okay, so you will see details on this, but a kind of a subset of this. This is the documentation that gives you really the in-depth stuff of what to do. Now, if you don't like reading or using web-based stuff and you want to have, say, an ebook, we do have a C2C ebook available, which is basically if you have a iPad or an e-reader or whatever, this is an ebook format. So this is exactly the same information that's online, but you're basically reading it as a PDF. So that's available to you as well. So you can use that. Okay, so let's go back to the containerization environment. So we want to do a shift, okay, from a traditional DB2 to a pod that's running on Cloud Pak for Data, OpenShift, or whatever. And you can see there's very little information that I need to have here. I just really need the name of the database, the instance owner, where's the target, and then details about the target. Okay, so let's quickly look at my system here. I'm going to say DB2 shift. And if I don't want to keep seeing the messages, I can say accept. So here, I want to do a shift. Give me a database name, an instance owner. So here's, for instance, I'm going to say DB2 list DB directory. And I don't care whether it's SMP, MPP, whether it's encrypted, whether it's columnar, or if it's row. We'll do all of it, right? So you can see I got a number of them here. There's trading, sample, banking, on time. So let's take, well, I'll do banking. Okay, let's just use the banking one. Okay, and I'm going to say I want to go to Kubernetes because I have a Kubernetes system. I need to know what is the name of the database there. And by the way, if you're moving this Cloud Pak for Data, it has to have the same name. So it's still got to be called banking. If it's just going to traditional OpenShift, Kubernetes, or a traditional instance, it could be a different database name. It doesn't have to be the same. So it ends up over here. Let's just take a quick look. Okay, I'm going to do a db2u. Oops, sorry. What is it called? Let's see if this works. Let's try this. There we go. So my project is db2u. So that is a or a namespace, and there is the name of my db2 pod. Okay, so that's what I need to know. So my database name in this case happens to be db2oltp because I just happen to remember off the top of my head. The project was db2u, and the name was demo db2u-0. Okay, so think of demo as your instance name. Okay, so that's it. That's the minimum that I need. Okay, and to run. Now I want to show you something before we run this. I could say review and execute, or I can say analyze. And what analyze is a neat little feature that will go and make sure that both your source and target are okay. And what I mean by okay, we check to see what the settings are. Now remember, I said an entire database moves, right? None of your settings have to be changed in the database. However, instance changes do not move. So what it does here is it shows me that there are some settings that are not the same between those two servers. So you'll notice right away that I have instance memory looks a little bit low, right? Intra-parallels turned on. Oh my gosh, if I don't have that turned on, my database is not going to work on the other side, is it? Right? You won't be able to do queries against it. I mean, the database will move, but so we are able to override settings at the instance level. So here, for instance, I may say, okay, let's change the instance memory and instance parallel. And I'm going to say, yes, I want to make sure that they got updated. And you'll notice down here, there's little overrides down there. So I'm going to ask it to do that at the same time. So I'm going to say, there's the command. Please go execute. So off it goes. Okay, so it's going to run and do a shift into a Kubernetes system. So again, this is exactly the same for Kubernetes, OpenShift. For Cloud Pak for data, you got to tell us that you want us to do the database shift. So there are some options below there. Metadata tells us whether or not you want us to refresh the metadata information. So we need some stuff out of the databases to tell us how to handle the file system, basically. You don't need to use this except if you're doing an upgrade from 10.5 or 11.1. And the reason is we need those databases to be offline. And so what you do before you do the shift, you say, give me the metadata. When that's done, then you do the shift with the database offline. We also have the ability to do rolling shifts. What that means is you can do a first pass, and we don't finalize. What it means is that we wait, okay, and then you can do refreshes during the day, just incrementally picking up any changes to the database. And then finally, when you have a maintenance window, you can say, okay, finalize. And we do one final pass, pick up anything that's changed, and then we finalize the database. So this is a nice way of doing it. If you have a lot of workloads running during the day, you can do an initial run and then keep doing refreshes every couple hours just to pick up stuff, and then do a finalize in the night or whenever you have a maintenance window. Okay. We have some move options. I just mentioned that if you are moving to Cloud Pak for data, you should set that flag to saying, yep, I'm going to Cloud Pak for data. And if you decide to use the database for HADR, there's a flag there because we have to do some special handling on HADR systems. We move all of your routines, by the way. So if you have store procedures that are so we move them, there's no difference there. We do that as part of the database. But if you have external store procedures, as long as they're sitting inside the traditional DB2 function library path, we will move them to the new location and basically move them and recatalog them. If, however, your stored procedures are outside the traditional DB2 location, we can't move them. Okay, and we'll give you an error, not an error, but a warning saying we can't do it. So you may say, don't worry about it, exclude the routines, I will do them later. You'll move them into the pod, then you'll have to catalog them. Okay? Database mode, this is online or offline. So online can be done with 11.5 only. You should do offline with 10.5 and 11.1 because that's a requirement for the migration step. Then we have two performance options. How many threads do you want to use and how much compression do you want? And we use a default of 4 for threads, and compression we set to 0 because we find that unless your network is really slow, like less than a gigabyte a second, adding compression doesn't really help you and actually slows you down because you're using more CPU. But if you have very poor network performance, then you might want to look at compression settings. Okay. Now, overrides, you saw what I did there. I said analyze, and then I said, there's some things I should change, and then I can tell it to update the target system. Okay, so that is an extra field available to you to update instance settings. Now, I want to make one comment here. We can't change environment variables, and this is something you're going to have to do or look for when you create a database in a pod for the first time. So in Cloud Pak for Data, there's a little flag that says Oracle compatibility. You turn that on, that means we set the environment variable before we create the DB2 database. If you didn't do that and you were migrating an existing DB2 Oracle compatibility database, it's not going to work correctly. I mean, it'll move over, but your SQL won't be correct. Okay, so you got to make sure your environmental variables are set properly before you shift over there. Okay, that's something we can't change. So there's a note in our documentation about that. Okay, so let's just go back to our little system here. You see the move is completed, right? We've now moved the database into the container. So if I were to go over here and I go, let me see if I have a Quebec tool. Let's see, I want to get a pod here. Oh, these commands are so hard to remember. I don't know. We're getting too old here to remember all these commands.
Indeed, we are.
Yep, like every time I do one of these Quebec tool commands, it's like 97 characters of doing something. Here we go. Oops.
Now you did it.
Yeah, it's okay. Now I copied it. It should be over here. Let's try it. There we go. Okay. So I'm sure everybody remember that off the top of their head, how to do that command.
Oh, yeah, for sure.
Yeah, all right, so DB2. And we should, I'm not sure this one has a different schema name. Oops, connect to DB2 OLTP. And I'm not sure this one is all within this now. It's got a different schema. So select distinct schema from syscat tables. Is it tab schema or tab schema, I think? This is why I hate my syntax. Why I hate this environment, actually. Okay, from
tab schema.
Yeah, tab schema. Yeah. There we go. So I think it's bank. There we go. So you see, if I say list tables for schema, well, you can tell already that it's shown up, right?
Bank.
Okay, there's no tables. Bank. All right.
And dress you up, you can't take you anywhere.
No, I can't. I know. All right, there you go. There's some tables. Anyway, so you can see it moved, right? So a good name. Now the thing is, this could be any database. I really don't care what you're running here. So that was a standard shift. So let's go back to our little utility here. So let me show you how I would have done this if I wanted to do an instance shift. So here I've got another server. I'm going to use banking again, just for the heck of it, right? I'm going to call it banking on server number 2. I'm going to say force the database creation. All I do is I give it the address of the database server, and I do exactly the same thing. I can say review and execute. I'm not going to change any of the settings. I'm going to say go. So watch what happens here. We check to see if the database sits on your physical instance, and we say, oh, it doesn't exist. I'm going to create the database. So off it goes. It's now going to create the database for you at the second server, and it's going to do a traditional DB2, move it over there, create the database, and off you go. Okay. So again, the only thing I need to know, name of the database, instance owner, target instance owner, name of the database, and away you go, right? So again, a lot of this stuff is pretty simple. If you just want to use the standard, I want to move it from A to B, you really don't have to do a lot to make it work. So I'm going to let that thing go. You'd be surprised. It takes a little bit of time to create the database because I have very small systems here. So let me now talk about cloning. This is something that you may use a lot, especially for DevOps. Cloning is exactly the same as doing a shift, but stopping before I actually create the target, right? So what we do is we get all of the metadata that we need for your database. We place all of the metadata and the control information and the file system objects into a directory. Okay, so that whole directory is what I move to my new location, or I store it somewhere. Now, as I said before, you need to treat it carefully because it contains the entire database content. So if it's encrypted, you don't care. If it's not encrypted, then you may want to, encrypt the data somehow, right? If you're leaving it around, so to speak. So pretty simple. You'll notice that here all I have to do is I have to give it the name of the database, the instance owner, and where I'm going to place it. And the process of doing that is very, very quick because we're just basically just moving some file system objects that we need. Now, people may think we're just moving a few little pieces of stuff. We're also moving libraries from the DB2 version that you're using because we use that for relocation and other stuff. Okay, so that's a clone. The deploy is exactly the same as a shift, but now instead of pointing to the database that I'm going to use, I'm pointing to the file directory that has the database objects in it. So you can see down here, it'll say, give me the database name, instance owner, and the directory, and then the target. Just the same as if I had done a shift to an instance or a shift to a cluster. Okay, so let's see how our thing is running here. So now you notice it's created the database. It's now going to copy all of the stuff over. So this takes a few minutes. You can see that it's running. So the utility as it runs kind of gives you some progress information in terms of the files, the objects, gives you a speed, right? You can see we finished. We suspend the database. We do a final suspend, okay? So the way this works is that your database is up and running until the final moment where we need to do like a final pass. So we do a write suspend, get the last blocks that have been written, and then there it's done. So I've now created a database available to me in my second server. So the way I can tell it exists, I'm going to go to server number 2. You can see my server number 2 will come up. I'm going to log in. You can probably guess what the name of the server is. The password. And we'll just expand the size. And you can see it's color coded too, so you can tell, right? And so I'm going to go with DB2. And if I list DB directory, you'll see all of a sudden banking is shown up. So there you go. You notice that we've now moved an instance over, right? Rather than into a pod, I've done it into a traditional DB2 system. So let's go back to our number 1 system here. I'm going to exit out of this. So we've done our move. Now, how would I have done this with cloning? Well, here, let's create a clone. Database name is banking. Put it into the cache directory. Run it. Okay, let's see how long does that take. Done the writes. Created the copy. So basically a few seconds. Now I now have a copy of the database that I need to move somewhere. So now that I've got that copy, I can now say deploy it. And I can deploy it into the container, or I can deploy it into an instance. I don't care. So here, just for the heck of it, this is scary, but we're going to try this. Okay. I can do it locally, so I can actually copy within my own instance if I want. I'm going to say banking again over at the other side. Okay. And I can just say, move it there. Oops. And what it does is it basically says, okay, I'm going to take that clone copy, execute it, move it to the one I just created. So it's going to take the copy, shift it, and I'll be done in a few minutes. Okay. So here it doesn't have to create the database because we already created it for us. Okay? So let that thing finish. So far, you're starting to get some ideas of how you can use this utility. Lots of different options here of how you can clone things, deploy things, very, very flexible. The other things that you may find useful is initialization of HADR, because that usually takes a little bit of thought, right, in terms of the commands to do that. So we've provided a utility here to say, set up an HADR connection between your traditional DB2 instance and a pod. And here we basically just need the database names. You make sure that you've created a copy of the database. So you already would have had shifted it beforehand, made sure you marked it as an HADR, right, environment. And then what you do is you basically say, run this utility, and it sets up the primary and secondary and have them up and running. So it's really, really convenient to set up HADR. You can also do it for an instance, so traditional instance HADR connection, and then you'll have a primary and a standby set up. So if we go back to my system here, this one's already done. You notice it already moved the database using a snapshot, a clone copy. So let's go back, and we're going to do an HADR shift. So let's do it this way. I'm going to shift the database. We're going to use a different one. I'm going to use trading. I think this is the right one. And we're going to, they have to have the same name, right? That's the one restriction, right? With HADR, the databases must be the same name. So I'm going to say, let's, oops, I can't do that, sorry. Apologies. We're going to go down here, and we have to say move database for HADR. Now, I don't remember if I've done all of the prerequisites for this, so let's see if it starts checking things. And so basically, I'm moving the trading database over to another instance. I'm going to create the database, move the data, and then hopefully put it in an environment so that it's ready to be used as a standby. Okay, so that's what it's doing in this particular step. So we're going to have to give that a few minutes to go through the process. But so far, you've seen me moving databases back and forth, right? This is not taking a lot of time to do this. So we're gonna wait for that, and then we talk about a few other commands. LDAP and DMC, this is only for CP4D movements. If you have done a HADR to a pod becomes the primary. At that point in time, you need to update LDAP and data management console. So this is only for those environments. Okay, other deployments, right, into instances, OpenShift, Kubernetes, you don't have to use this at all. The copy to clone utility is also part of this UI, and it allows you to basically copy a clone into a pod or out of a pod. And the reason for that is, let's say you want to undo your migration, right? So you go in a pod, you say create a clone using the utility, and then what you do is you can extract it using this particular command. It's really, you could have done this yourself, but there's a number, you'd have to understand some of the Kubernetes and OpenShift commands to do the movement of the data. So we use this utility. By the way, if you are using the utility, and here, for instance, I'm going to show you, I am still in, I believe, nope, okay, I'm gonna go back into my Amazon system, and I'm gonna just show you something here. And we're gonna bring up Shift. By the way, we have shortcuts. So you can say Shift Pod, and you go right to the menu, okay? At any time, if you don't know what a particular field is, right, you can do Control F, right? So it'll give you detailed information of every field. When you go and do, for instance, the analysis step, right? So for instance, if I do analyze here, if I do the Control A, comes back and it'll say, here are the things that are different between the two systems. We give you detailed information on all of the different parameters that DB2 is looking at. So you'll notice here authentication or instance memory. Let's say you want to know about instance memory. If you do a Control F on that, right, it'll say specifies the amount of, if you are in an operating system like Mac or Windows, you'll notice that I can go across this and shift, in many cases, I'll be able to shift on the link, okay? Now, this may not always work depending on what frickin' version I've got, okay? But normally, I'll be able to click on this and it actually goes to the web page. But that is only when you are in a environment that supports clicking on it, right? So in this case, it looks like my window doesn't support it. It does in Linux, okay? Anyways, if you'd seen it, it would have been beautiful to watch. But anyway, okay, let's see what's happened over here. Okay, success. You notice now it says transfer completed, DB2 started in mode ACS standby. Okay, so I've moved my database now. Now I have to go and say, set up HADR. So let's go to that step. And the database name was trading. The IP address of my machine, in this case, this is where I'm coming from. I'm going to 10.0.0.2. Okay, database names have to be the same. And I'm going to say, there's the command. And what it does now is it starts the secondary. And you'll see it'll start up. And in a second, it should come back and say it's ready in standby mode. Keep your fingers crossed. And then once it's finished that, it will then go off and try and start. There it is, started the HADR. There's the secondary now, is a near sync. And you'll wait for HADR primary, done. We now have HADR running between my source and my secondary. And I can now wait for them to catch up, and they will continue to be a primary and a standby pair. And I've also set up read-only on secondary, so I can make updates on the primary, and you can see it on the secondary. So I won't bore you with that, but as you can see, how long does it take you to do this kind of thing, right? Just imagine the amount of time and effort it takes to run many of the commands. Now, if you are curious, whenever we do one of these things, we do have a log file that's created. So if I say shift the log file, you can see everything that we've done. We place all of our SQL commands, all the things that we've done, the results that we get back in these log files. So you can always go back and see the details, okay? And they're kept for every run. Also, if you want to do a local database analysis, you can do it here as well. So for instance, if I put the trading database name in here and I said analyze, it'll connect locally and come back with all the settings that it has that may be different from the target server. Okay, so you can determine whether or not you can move this thing okay, right? So the biggest ones I usually see are instance memory, or some parallelism is not quite the same, etc., right? So there you've seen a couple of scenarios run. So the first thing that everybody asks me after I've shown them this is, what is it going to take to move the database? How long will it take? And there are two things we provide, right? The threads and the compression. From threading is the biggest one from a performance point of view, because the threads determine how much parallelism I get on the movement of the data objects. And we can allow anywhere from 1 to 8 threads. And 4 is a good balance, but again, the more threads you use, more CPU, the more overhead, right? So something to be aware of. Compression, on the other hand, the default is 0, all right? I would not use it unless I have very slow network performance. Okay, we found that less than 1 gigabyte, yeah, okay, use 1 or 2 compression. Anything over 1 gigabyte, don't bother, okay, because you're just adding more CPU overhead. So we did a benchmark on our cluster that I've been running with lately, and ran this hundreds of times to find out what is the best mix of performance. And this is what we found on our AWS server. We found that as we increased the number of threads, we didn't get any faster elapsed time. You'll notice here after about 4, it was about the same. And you'll notice that the copy time was about the same. Okay, so then we took a further look and we looked at the network throughput versus CPU utilization. You'll notice the network is being hammered at the same time the CPU is busy, right? Which kind of makes sense, right? Because we're sending a lot of data. So this is what we call the copy phase here. And it ends up that our network between the two servers is limited at 5 gigabits a second. So one thread can only pump out about 1.2 megabits or 1.2 gigabits a second. So once you're up to 4 threads, you're saturating the network. So that was your limiting factor. So to determine your throughput, what you do is you run your a shift on some sample data. We see how much one thread can put out, and you take that and divide into your gigabits per second, which gives you the number total of threads that you need. Okay, so in other words, when we did this calculation, okay, you can follow if you want, we figured out an ideal condition would be 128 seconds to move the data, because we knew the size of the data, we knew how much gigabits per second per thread, and we said, okay, and we observed 131, not bad, pretty close. So it's all down to what's the speed of your network and how fast can a thread move the data. Now, from our testing, we found that we can do about 4 terabytes in an hour on a 10 gigabit Ethernet system. Okay, that's if I have all the bandwidth to myself and I have optimal CPU performance. Okay, so if you got a faster network, you're going to go a lot faster. From a compression point of view, you can see it's pretty ugly, right? There's our transfer rate with 0 compression. As soon as I go down to using compression of 1, I get just under a gigabit a second throughput. So what that means to us was that if you have a very slow network, then yeah, go ahead and do 1, right? Maybe 4, but certainly don't use the highest level of compression. You just end up spending a lot more time in CPU usage than actually running anything. Okay, so let me give you a summary of what you've seen, right? C2C or Db2 Shift can take a normal Db2 database running on Linux, whether it's x86 or Power Little Endian, and we can containerize it. We can move it into a traditional Db2 or an OpenShift, Kubernetes, or Cloud Pak for data. We can move it into multi-tenant Db2. That means the pods can have multiple Db2 databases. So we can shift into one of those, right? We can do SMP, MPP, columnar, compressed, encrypted. We can do upgrades for you from 10.5, 11.1, right, up to 11.5. We can do cloning, which is very useful for DevOps, right? We can clone and then deploy to any of those environments. And we can tune how fast we can move this stuff. So it's a really unique utility. It's going to be shipped as part of 11.5.8, okay, which will be available next quarter. And it is part of the Db2 development team. So it is what I call a first-class utility being supported, through your regular PMRs, etc. So it's a utility you should explore and look at using, especially when you want to modernize your Db2 workloads, or if you just want to use it to move to other Db2 environments. So here are some links to resources. We have a download site. It's called IBM.biz C2C download, which will give you the technical preview version of what I showed running. We have the PDF or the HTML guide available to you. We also have a lab that you can get access to, but you need to ask your IBM either tech salesperson or salesperson to give you a image. They basically request an image for you and you get to use it for up to 2 weeks. And we have a lab that goes through a lot of details on how to use Kubernetes, create a Db2, etc., and all those scenarios that I showed you. And we also have a single-page fact sheet if anybody wants just a little bit of a marketing blurb of the product. So with that, that's C2C, and I hope you found that interesting and insightful, and that you take the opportunity to try it out yourself, because I think it's a very valuable utility, especially when it comes to modernizing your Db2 landscape. So with that, back to you, Martin. Thank you.
Thanks. I've got a question from Sanjay here. Will I be able to make standalone databases to HADR with a primary and secondary, or standby, primary and standby, by using this move, clone, copy utility?
Yes, you can. So the way you would do it is you would, first of all, clone or shift the database to your target location. Okay, so that would be step one, and you make sure you save for HADR mode, right? Once you've done that, then you go and say, okay, I want to now connect the two of them. That's that second step, the HADR, and we'll have them up and running. So here are some restrictions you should be aware of. HADR obviously only works on traditional Db2. It will not work on MPP systems, right? If you're going to go to a pod, so you go from a traditional instance to a pod, that is supported, but we do not support pod-to-pod HADR. So we don't, that takes some special commands within the Kubernetes or OpenShift environment to get that to work. So we are only HADR between a traditional Db2 to a pod or traditional Db2 to another traditional Db2. Okay, but that's fully supported by this utility.
Okay, I guess that's it for questions. So let me take back control and we'll wrap up the show.
Thank you.
Thanks for a great job as always. Let's have to find the attendees here and make myself the presenter.
Right.
There we are.
And you will have a copy of the presentation available, and I guess on the website.
Do, and it'll be available on our replay blog shortly, as soon as I get through all that processing stuff. So now I'm presenting, and with that, I will go here. We got our final question to ask as well, our polling question, which is, and that question is, did you learn anything today? And let's see what people say about this. There we are. And there we got people voted, so we'll share that. And the answer is 100% of our studio audience has learned something. It's absolutely fantastic and what we love to see. So, as always, George, a great job. I'll cue the music here, and we'll give back people the remaining part of their day. Oops, I got to hide that first. My goodness, it's taken a long time. I haven't put new batteries in my thingy.
I'll send you a new mouse.
Yeah, such is my life. All right. Turn up the volume. There we go. So have a great weekend, everyone. And we'll see you next time on the DB2 Night Show, in 2 weeks for a Z show, and next month for the next LUW show. Goodbye to all, and thanks again. Bye-bye.
Thank you. Bye-bye.